and because the green object is new, they're probably just scared of it and don't want to explore it more. Secondly, we looked at the present explore time, this time for both the novel object and the familiar object in the het mice and the wild type mice. So what we expected to see, as I mentioned previously, was that the wild type mice, which is the white bars, would explore the novel object way more than the familiar object, and that the het mice would explore the novel object and the familiar object the same. And so as you can see in the bin 1, which was the first 5 minutes, it was not the case. In fact, it was basically opposite. And so again, we think that is because of the neophobia affecting the wild type mice and the het mice being less anxious. However, in bins 2 and 3, which are 5 through 10 and 10 through 15, the wild type mice here explored the novel object significantly more than they explored the familiar object, and the het mice explored both objects about the same amount of time. So that is good because that's what we expected, so it's always good to see. Our next graph is essentially the same data that I just showed in the other graph, except this time we broke it down. So we have the het mice here, and then we have the wild type mice, but then we have the female het mice, the female wild type mice, the male wild type mice, then the female het mice, and the male het mice. So so what we really noticed from this graph was that in the last 2 bins, which is this one and this one, well, the males did explore the novel object way more than the familiar object. The females explored them about the same amount of time. There was no significant difference. And so this is really interesting, and what we think this is from is because we believe that the female mice are blunted. In our lab, we usually use black 6 mice because they are highly active and not very anxious. And so now we're talking to the lab that we got the mice from and seeing if they had a genetic background abnormal to these black 6 mice. So in our last graph, it compares the hand score data, which is the data I took sitting at the computer and watching all the videos, with the auto score data. And so what our lab has is this program that actually tracks the videos of the mice. And what it has is it has a point on the mouse's nose and a point on the mouse's tail, and it tracks when it's within this vicinity that's drawn around both objects. And so as you can see, the graphs are pretty similar, which is very, very good because that means the computer program is accurate. And this is exciting to see because it's really time consuming to watch all those videos. I know I watched 20 hours of them. So that's really good because then you don't have to sit at a computer and it's much more efficient. So as far as future research goes, the lab is currently designing new tests to look at anxiety in these mice because we believe it's a prevalent issue. Also, the research that we did is basic research, which means it's research that's done for the purpose of simply knowing. But basic research is really important, especially in this case, because it can go to provide a baseline that can prove or disprove future treatments and therapies for Kabuki Syndrome. In addition, the Raber lab is also looking at 440H tau mice and the relationship between tau and the development of Alzheimer's-like diseases, and they're especially looking at the correlation between smoking and its potential lasting effects on people predisposed to Alzheimer's. I would like to thank St. Mary's Academy, Mrs. Dashel for teaching the SRM class, as well as OHSU, Dr. Jacob Raber for letting me in his lab, as well as my mentor, Sydney Weber, for taking her time to teach me all about the scientific research process.